ZIMPOLSPHEREPDR observations of HD 169,142 in VBB. Credit Bertrand et al. 2017. Phys.org. A new study based on observations conducted via the Zurich Imaging Polarimeter ZIMPOL reveals insights into the nature of a protoplanetary disk surrounding the star HD 169,142. The research, presented in a paper published November 24 on arXiv.org, uncovers substructures and offsets in the dust distribution of the inner part of the disk. Located some 380 light-years away from the Earth, HD 169,142 is a young, about 6 million years old Herbig-Ae star approximately 2 times more massive than our Sun. The star is known to be orbited by at least one massive gas giant planet and has a protoplanetary disk. The disk surrounding HD 169,142 has been the target of numerous observations from the near-infrared to the wavelength range. These observations reveal that this disk consists of thick bands of dust separated by deep gaps. HD 169,142 was found to have a cavity with a radius of about 16 astronomical units and an annular gap present at approximately 32 to 56 astronomical units. More recent study detected a residual disk at about 0.16 to 0.48 astronomical units from the star, and a third narrow gap was found this year at a distance of about 85 astronomical units from the star. Now, a group of astronomers led by GESAHM Bertrand carried out new observations of HD 169,142 with the aim of learning more details about the structure and properties of its disk. For the studies, they employed the ZIMPOL polarimeter, which is a subsystem of the spectropolarimetric high-contrast exoplanet research instrument SPHERE at the Very Large Telescope VLT in Chile. ZIMPOL allowed the team to probe the disk as close as 3.5 astronomical units to the star and to trace the disk out to approximately 126 astronomical units. These observations generally confirmed previous results and revealed indications for planet-disk interactions, such as small-scale structures, star disk offsets, and potentially moving shadows. In this work, we present our new SPHEREZIMPOL data on HD 169,142, which confirm the previously found gap structure and reveal yet undetected indications for planet-disk interactions in the form of substructures and offsets in the dust distribution of the inner part of the disk, the paper reads. The research confirms that the disk surrounding HD 169,142 is flat, self-shadowed and is interacting with the star. In particular, the study revealed complex, irregular substructure of the disk's inner ring and its offset position relative to the star. This ring also exhibits a surface brightness dip. The researchers suggest that these results could be explained by 3 giant planets located at 15, 35 and 45 astronomical units from the star, which could form the bright inner ring with its substructures as well as the surrounding gap. The study also found that the gap separating the bright inner ring from the outer disk is not annular, as previous observations suggest, but of elliptical shape. According to the authors of the paper, this could be due to a circular outer disk that is observed under an inclination of 13 degrees. In general, observations performed by Bertrand's team shed some new light on the nature of the disk around HD 169,142 and could improve our knowledge about many aspects of star and planetary formation. This is because circumstellar disks around young stars are the key to understand these formation processes. Studying disk evolution and dispersal could offer better understanding of the origin of planetary systems. Explore further. Scientists investigate debris disk in a nearby planetary system. More information. HD 169,142 in the eyes of ZIMPOLSPHERE arXiv 1711.0904 *. pparchive.org abs 1711.09040 abstract. We present new data of the protoplanetary disk surrounding the Herbig ABE star HD 169,142 obtained in the very broadband VBB with the Zurich Imaging Polarimeter ZIMPOL, a subsystem of the spectropolarimetric high-contrast exoplanet research instrument Sphere at the Very Large Telescope VLT. Our polarimetric differential imaging PDI observations probe the disk as close as 0.033.50 to the star and are able to trace the disk out to approximately 1.08 to 126.0. We find an inner hole, a bright ring-bearing substructures around 0.18210 and an elliptically shaped gap stretching from 0.25 to 0.47 2955.0. Outside of 0.47, the surface brightness drops off, discontinued only by a narrow annular brightness minimum at approximately 0.630.747,487.0. These observations confirm features found in less well-resolved data as well as reveal yet undetected indications for planet-disk interactions, such as small-scale structures, star disk offsets, and potentially moving shadows. Copyright 2017 Phys.